Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on substitution and algebraic terms. So we'll start off by looking at substitution. So you might have a rule like this, for example, y equals 2x plus 5. And you are told to substitute, which means exchange values for the pronumerals. So this here is a rule because it has two variables, x and y. And one of them is the subject of the equation. Y is the subject because it's y equals something. So what we might be asked to do, we might ask to find y. What will be the value of y if, let's say, x equals 3? So all we do is we take our expression, we get rid of x, and I'm going to exchange that for 3, because x is 3. Now note, 2x doesn't mean that the first digit's 2 and the second digit is x. It's not 23, it's 2 times 3. So y would just be 2 times 3, which is 6, plus 5 is 11. How easy is that? Let's look at another example. So let's look at this question here. So this time I'm given not a rule, but an expression involving a's and b's, and I have to substitute the value of two pronumerals. So what I'm going to do is I'm just going to quickly rewrite this expression. Now I'm told that a is minus 2. So everywhere I see an a, I'm going to replace it with minus 2. So I put a minus 2 here, and I'm going to get rid of this a here, and make that into a minus 2. Of course, 3a means 3 times a. And then I simply do the same for b. Get rid of b, and I'm going to change it to 5 because I was told b is 5. So the value of this expression is minus 2 times 5. So remember, I have to do the multiplication first. And on the bottom, I get minus 6. So minus 2 minus 10 is negative 12. Divide by negative 6 and you get positive 2. So that is the value of the expression. How easy is that? Now we're going to look at algebraic terms. So let's look at what we have here. So this here is called an expression. So it's just, a whole heap of terms. The terms are separated by plus and minus signs. So this is one term, this is another term, and this is another term. So here there are 3 terms. So basically a term is just a sequence of letters and numbers stuck together. So just before we go on, I'll just say this has a special name because it's a term with no pronumerals. We call it a constant term because it doesn't change its value. It's always 2, whereas x changes its value. Could be 1, could be 2, whatever. So we're going to look at performing the operations on these terms, these sequences of letters and numbers. So hopefully you all realize that x plus 7, y plus 2, it cannot be simplified. I can't actually add these 3 terms together. And that's because when I'm trying to add and subtract terms, you can only do this, you can only add and subtract terms if they're like terms. So remember, you would have come across like terms last year. Like terms means it has the same sequence of letters. And of course, pronumeral just means letter. So if I have something like 7x plus 2, they're not like terms. So they cannot be added, just like the expression up top in red. So I can't simplify that any further. If I have something like 7x plus 5x, I can simplify that. This term has 1x, this term has 1x. They have the same sequence of letters. So in this case, I just add the coefficients, which is the number in front. So 7x plus 5x is 12x. How easy is that? It works very similar for subtracting. If I have like 12a minus 8a, so they are like terms because they both have an a, so I can subtract them. I just subtract the coefficients. 12 minus 8 is 4, and I have 4a. Or if you like, if you think of them like apples, if you had 12 apples, you take away 8 apples, you have 4 apples left. So if I have something like this, 6x plus 3 minus x. So in this case, I have 1, 2, 3 terms. 2 of them are like terms. 6x and x are like terms. So I do the operation with them. So 6x minus x is the same as minus 1x. It gives me 5x. I can't do anything with the 3 because it's not a like term, so I'll leave it exactly as it is. So let's say I have something like 7ab plus 3b minus 2ba, okay? So there are again three terms. This term and this term are like terms. It doesn't matter if the pronumerals are out of order. They both have 1a and 1b, therefore they're like terms. So 7ab minus 2ba is just 5ab or ba. Now, the 3b doesn't have a like term, so I leave it as it is. B and AB are not like terms. The first term here has an A, the second term does not. They do not have the same sequence of pronumerals, therefore you cannot add or subtract them. So now we're going to have a look at multiplying and dividing terms, which is quite a bit simpler. So let's say I have something like 3a times 2. Now 3a and 2, they are not like terms, but we can still multiply them. So you can only add and subtract like terms, sort of like you can only add and subtract fractions that have the same denominator. You can multiply fractions if they don't have the same denominator, and the same here, you can multiply terms even if they're not like terms. So because 3a times 2, timesing by 2 just means adding it to itself. Is 3a plus 3a, they are like terms, add the coefficients, okay? So you might note what I've done here is I've just multiplied the coefficients, and that's how I do it. So let's say I have 5p times 7b. So do the numbers and letters separately. 5 times 7 is 35, and then let's just write the letters, the pronumerals. Let's say I have negative 13xy times negative 2z. Do the numbers separately. Negative 13 times negative 2 is positive 26, and then you write the letters. X, Y, Z. Fantastic. Now let's look at division. So division is similar in that you can divide terms even if they are not like terms. So let's say I have something like 12a over 6, okay? That's the same as 12a divided by 6. So again, do the numbers separately. So 12 divided by 6 is 2, and then I just write the letter here, okay? If I have something like 5a over 20, it's a bit more complicated. It's still a division, but we're going to treat it like a fraction. So remember how you simplify fractions, you find the highest number that goes into the top and the bottom. So that's 5. 5 goes into itself once, goes into 24 times, and so I'm just left with an a on the top. A and 1a are the same thing, and a 4 on the bottom. If I have something like this, let's say xy over 6x, these two do have a common factor of x. If something appears on the top and the bottom, you can cancel it out. So the two x's, because x divided by x, any number divided by itself just equals 1, I can cross it out. I'm just left with y over 6. And that's all there is to it. So I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.